There is a mining pit on Isle Royale, in the middle of Lake Superior, that contains a stone maul weighing approximately 30 pounds. A birch bark container that collapsed into the silt around it roughly 8 centuries ago, and a mass of native copper weighing perhaps 40 pounds that the person who made the maul and carried the container had been in the process of separating from the surrounding greenstone when they stopped. The work is half finished. The copper is still there, still partially attached to the rock at its lower edge. The upper surface showing the characteristic hammering marks of the ancient Lake Superior method. Thousands of blows from the stone maul, incrementally freeing the copper from its matrix. The stone maul is where the workers set it down. The birch bark container is where it was left. Nobody came back. And that pit is not an unusual case. It is one of more than 1,000 ancient mining excavations on Isle Royale alone, and the pattern it represents: tools in place, copper half extracted, work abandoned mid-process, repeats across site after site on the Keweenaw Peninsula, across the Upper Peninsula of Michigan, and along the copper-bearing ridges of the Lake Superior Basin. For approximately 9,000 years, a continuous tradition of organized copper extraction worked these deposits. And then, within what the archaeological record suggests was a very short period, possibly a single generation, it stopped. The tools were left where they lay. The copper was left in the pits. Nobody came back for any of it. I came to this through the Geological Survey. I had been reading 19th century mining assessments of the Keweenaw Peninsula, the finger of land extending into Lake Superior from the Upper Peninsula of Michigan, trying to understand why the first American copper mining operations of the 1840s were so immediately productive, why they found workable lodes so quickly in a region where surface mapping had been limited. What I found, in the published portion of the 1841 survey conducted by Douglas Houghton, Michigan's first state geologist, was a passage I did not expect. Houghton wrote that the ancient mining pits his survey team encountered followed the productive copper lodes with an accuracy that our own surveys have confirmed. That the ancient miners had located the most economically viable sections of the copper deposits, with a precision that Houghton compared favorably to contemporary geological survey methods. He noted that in several pits, the ancient work had stopped exactly where the copper vein thinned below economically viable extraction rates, not randomly, at the point where a competent geological assessment would have advised stopping. I went looking for the rest of what Houghton had written, and I found a letter in the Smithsonian Institution archives indicating that the rest had been held. By the time we reach the end of this, you will understand why 9,000 years of the most sophisticated pre-industrial mining tradition in human history ended when it did. What the geological evidence says about how the people who maintained that tradition understood their own work, and why the notebooks that would have documented that understanding were directed in 1857 to be held pending review by the Smithsonian's secretary, pending a review that was never completed and whose outcome has never been publicly described. I want to be clear about what I can establish. I cannot tell you what is in those notebooks, because they have not been released. What I can show you is the outline of what Houghton found, and what the oral tradition of the people whose ancestors did this mining has preserved about why it stopped, and why those two sources, taken together, tell a story that the published record of American mining history has not absorbed. The scale of ancient Lake Superior copper mining is something that takes a moment to settle into. The deposits of native copper, copper in its pure metallic form, not needing smelting, workable directly by cold hammering or by alternating heat and cold water treatment to reduce its brittleness, are the largest in the world. The Keweenaw Peninsula and Isle Royale together hold native copper deposits whose ancient exploitation produced, by various estimates, somewhere between 1.5 billion and 2.5 billion pounds of extracted copper. That range is large because the estimates derive from the volume of ancient mining debris, the broken rock removed to access the copper, rather than from direct measurement of what was taken. But even the low end of the range is staggering. 1.5 billion pounds of copper, removed by hand tools, transported primarily by birch bark canoe, and distributed across a trade network that carried Lake Superior copper to the Gulf of Mexico, the Atlantic coast, and the Rocky Mountain foothills, beginning approximately 9,000 years ago and continuing for millennia. The Hopewell culture of Ohio, whose burial mounds contained extraordinary quantities of worked copper objects, was obtaining that copper from Lake Superior. The copper gorgets and ear spools of the Mississippian period, found across the southeast, came from the same source. The copper that made its way into the coastal cultures of what is now Georgia, into the plains cultures of Kansas and Nebraska, into the Pueblo cultures of the Southwest. Lake Superior copper, worked by the Lake Superior tradition, distributed through a commercial and ceremonial network of continental scale that operated for longer than the entirety of recorded Western history. Consider what the organization of that tradition implies. A continuous mining operation of 9,000 years is not a series of independent discoveries. It is an institution, a body of knowledge, maintained and transmitted across generations, about where the copper was, how to access it, how to work it, how to move it, and what to do with it. The logistics alone are staggering. Transporting copper from Isle Royale to the Gulf of Mexico required a relay system of trade partners, established routes, seasonal timing, and the maintenance of relationships across hundreds of miles of diverse terrain and dozens of distinct cultural groups. A mass of copper moving from a Lake Superior mining pit to a burial mound in Ohio to a ceremonial site in Georgia to a coastal cache in Florida did not travel in a single journey. It moved through a network that had to be organized, maintained, and trusted across generations. That network existed. It functioned. The copper arrived, and the tradition that sustained it, the knowledge of where to mine, how to judge when a deposit was worked out, and how to move the product to where it was needed, was transmitted without interruption for longer than the entirety of Egyptian dynastic history from Narmer to Cleopatra. The Anishinaabe people, whose ancestors are among those who maintain this tradition, have oral accounts of the copper that are specific about its nature and specific about what happened when the mining stopped. In those accounts, the copper is understood as a living entity whose accessibility was not a fixed geological fact, but a relationship that required appropriate conduct on the part of the people working with it. This is not a primitive explanation. It is a description, encoded in the form traditions used to carry practical knowledge across time of what a miner who had worked a deposit for generations would understand about its character. That it is not infinitely available, that it requires reading and interpretation, that it has conditions, that it will withdraw from inappropriate use. The oral tradition says the copper withdrew. The geological record says the accessible surface deposits were substantially exhausted. Those are descriptions of the same event in different registers of language. This is the part I keep returning to, because Douglas Houghton's 1841 published survey notes that the ancient mining pits his team mapped showed the ancient miners stopping at the geological transition points, where a rational extraction decision would have counseled stopping. Not randomly, not from panic or sudden abandonment. At the boundary where further work would have yielded diminishing returns, where the vein pinched, where the copper occurred in smaller masses, where the investment of effort would not match the yield. This is a geological observation about ancient decision-making. It implies that the people who made those decisions understood the geology of their deposits with enough precision to identify the optimal extraction boundary. They were not blundering through the rock. They were surveying it. And the survey, extended across the full productive life of the deposits over 9,000 years, had reached a conclusion. The accessible copper at the surface extraction depths the ancient technology could reach was substantially gone. The tools left in the pits are not evidence of sudden flight. They are evidence of finality. You do not carry a 30-pound stone maul back to your canoe if you are not coming back to use it. The tool is heavy, and the birch bark canoe has limited capacity on open lake crossings. When a miner set the stone maul in the pit at the end of the work, they were not abandoning it under duress. They were leaving it in the place where it had been used, because the place and the maul had served their purpose, and neither would be needed at that location again. This logic extends to the copper itself. The mass of copper still partially attached to the rock at the pit's lower face, half extracted, the upper surface showing generations of hammering, was not left because the miner ran. It was left because finishing the extraction and moving the mass to the surface, and then to the canoe, and then across the lake, was not worth the effort, given what the geological assessment of the surrounding rock had already indicated about the remaining yield. A miner who has been reading a deposit for their entire working life knows when the work stops being productive before the accounting desk tells them. The abruptness of the abandonment, tools in place, copper half extracted, the pattern repeating across hundreds of sites across a region, is not the signature of catastrophe. It is the signature of a systematic decision executed methodically at site after site across a generation. Not overnight in the sense of panic. Overnight in the sense of a conclusion that had been building for decades, finally acted upon. The tree ring data confirms the timing. Dendrochronological records from the Great Lakes region show a period of sustained cold and disrupted seasonality beginning in the late 12th century C, approximately 1178 to 1210. A period of climate instability that would have affected the seasonal travel patterns on which the copper trade depended in specific and practical ways. Birch bark canoe transport on Lake Superior is genuinely hazardous in conditions of high wind and cold. The lake sits at elevations where sudden weather changes are common, is cold enough year-round to kill within minutes of immersion, and is large enough to generate open ocean swells, dangerous to the kind of craft the copper miners used for their transport runs. The seasonal window for safe canoe travel on the open lake is narrow under any conditions. A generation of colder, more unpredictable seasonal patterns would have narrowed it further. The trade network that distributed the copper, which required reliable seasonal movement of goods across those lake passages, would have experienced disruption first, before the mining itself stopped. A disrupted distribution network reduces the incentive to continue extraction at full pace. The copper piles up at the source when it cannot move efficiently, and when the deposits yielding that copper are themselves approaching geological exhaustion, the combination of disrupted distribution and diminishing extraction yield is the rational occasion to stop. The climate shift did not cause the mining to end in isolation. It was the final logistical pressure on a process, the geological exhaustion of the accessible surface deposits that the miner's own survey had been tracking for generations. The confluence of those two forces, at that moment, produced the pattern in the pits, tools set down, copper left in place, no return visit. And then there are the notebooks. In 1845, Douglas Houghton drowned in Lake Superior during a storm while conducting his survey work. He was 36 years old. His field notebooks, including the notes from the 1841 Keweenaw survey and subsequent fieldwork on the ancient mining, passed to his widow and eventually to the Smithsonian Institution. In the Smithsonian Institution archives, in the records of Secretary Joseph Henry's administrative correspondence, there is a letter dated 1857 from Henry to Houghton's widow, acknowledging receipt of the notebooks and describing his assessment of their contents. Henry wrote that the notebooks contained observations on the ancient mining operations that he considered too speculative for publication in their present form, and that he had directed that they be held pending review by appropriate scientific authorities. Too speculative for publication. Directed to be held. In 1857, the Keweenaw copper rush was at its height. American mining companies, the Pittsburgh and Boston Mining Company, the Quincy Mining Company, the Cliff Mine Operation, the Minnesota Mine, were extracting copper from the same deposits the ancient miners had worked for 9,000 years. From shafts and adits that in many cases followed directly down from ancient surface pits and used the ancient pits as their initial survey reference. The irony of that dependence was visible to anyone who looked. The American mining industry of the 1840s and 1850s located its most productive operations by finding the ancient pits, reading the ancient geological assessment, and extending it downward. The property claims underpinning those operations, federal land patents granted under the 1846 Treaty of Fond du Lac, state mining leases, private purchase and development agreements, rested on the assumption that the deposits they were working were commercially virgin for legal purposes, that the prior ancient use had not substantially depleted the economically viable copper, and created any claim on the resource that American property law was required to recognize. Houghton's published survey had already noted, carefully, that the ancient miners had followed the productive lodes with considerable accuracy. If the unpublished notebooks contained a fuller development of that observation, a systematic argument that the ancient Lake Superior miners had conducted a competent geological assessment of the deposits across their full productive life, that they had stopped when the survey said stop, the implications for property law in the Keweenaw would have been complex in ways that nobody in 1857 was positioned to absorb. Not because the ancient miners had legal claims under American property law. They did not. But because of finding that the most productive deposits had been substantially worked for 900 years by a systematic tradition that knew what it was doing, would have required acknowledging a prior user relationship with the resource that the legal framework of 1857 had no mechanism for recognizing. The review that Henry directed has not been publicly described. The notebooks have not been publicly released. The Keweenaw copper mines, the American ones, the ones that operated from the 1840s through the 1960s, are now closed. The deposits that supported the world's most productive copper mining region for a century of industrial operation were exhausted by roughly 1970. The ancient miners stopped when the accessible surface deposits were substantially exhausted. The industrial miners stopped when the deep deposits were substantially exhausted. Both traditions worked the same resource to the limit of their technology's reach, and then stopped. The difference is that the ancient tradition encoded the stopping as a decision. The copper withdrew. The relationship ended. The time for that work was complete, while the industrial tradition encoded it as depletion, a straightforward economic fact with no relational content. Both descriptions are accurate accounts of the same geological event. The tradition that carried its knowledge for 9,000 years understood the copper as something that had conditions. The tradition that arrived in the 1840s understood it as a commodity. Both traditions exhausted what they came for. What the stone mall on Isle Royale represents is not mystery. It is record-keeping of a different kind. The material signature of a systematic, generation-spanning, geologically sophisticated operation that worked a resource for longer than any other industrial tradition in human history, and stopped, methodically, when the work was done. The question the archaeological literature has devoted considerable effort to answering: why did they stop so abruptly? Why were the tools left in place? What disaster or disruption ended the tradition? Has an answer that was available in the oral tradition all along, encoded in a form that the academic archaeology of the mid-20th century was not looking for. and did not ask. They stopped because the survey said, "Stop." The tools were left because you do not carry heavy equipment back to your canoe when you are not returning. The copper withdrew because the accessible copper was substantially exhausted, which the miners understood before anyone else did, because they had been reading the deposits for 9,000 years, and they knew what the rock looked like when it was nearly done. The notebooks that would have documented Houghton's understanding of this, that would have connected the geological precision of the ancient mining decision to the oral tradition's description of the copper's withdrawal, are in the Smithsonian Institution archives. They have been there since 1857. The review that Henry directed has not been completed, or has not been described publicly, or has produced an outcome that has not found its way into the literature of either American mining history or the archaeology of the ancient Lake Superior copper tradition. That literature is large. The notebooks are not in it. If this is something you find yourself sitting with, share it with someone who has been taught that pre-contact North America had no industrial tradition worth the name. Because 9,000 years of organized geological survey, systematic extraction, continental scale distribution, and rational termination when the resource was exhausted is not the absence of industry. It is industry operating across a time scale that the civilization that replaced it has not yet matched.